All right, today we get to learn about some multiplication properties of exponents. We're going to start out by trying to get you to figure out one of the main ones by yourself. So I want you to explore a little bit. Definitely have a pencil out handy and try to do this. I want you to write out n to the third in expanded notation. So without any help from me, write out what n to the third means. Okay? I hope you wrote n times n times n. Okay? If I ask you to write out n to the third times n squared in expanded notation, please go ahead and do that. So now I have n to the third, okay, times n squared. Okay, so now I see n times n times n times n times n. Now I'm going to ask you to simplify your expanded notation using one base and one exponent. Okay, so now you're going to look here what you have and try to write that with one base and one exponent. I hope you wrote n to the fifth. Okay. All right, I want you to do the same process with all of these three things. So 2 to the fifth times 2 to the fourth, a to the third times a squared, and then y to the fourth times y cubed times y squared. Okay, so I want you to write it all the way out and then write it with one base and one exponent. Okay, and you can pause and then check. So if you wrote this one out, 2 times 2 times 2 times 2 times 2, that's 2 to the fifth, and then 2 times 2 times 2 times 2, that's 2 to the fourth, and we're multiplying these two things, so you should notice we get 2 to the ninth. Okay, same process with these. You should have gotten a to the sixth when you did this one, and you should have ended up with y to the ninth when you got this one. Okay, what I want you to think about, to multiply with powers with the same base, what seems to be happening? Okay, when I multiplied n to the third times n squared, I got n to the fifth. And I multiplied y to the fourth times y cubed times y squared, I got y to the ninth. I hope you kind of see that you can keep the base and add the exponents. Okay, so to multiply powers with the same base, you can keep the base and add the exponent. Hey, the teacher says, hey, this is very important. Okay. Here's the property written in algebraic symbols. So when you're multiplying powers with the same base, the property says for every non-zero number a and integers m and n, a to the power of m times a to the power of n equals a to the power of m plus n. So exactly what we just said before. If these have the same base, we keep the base and we add the exponents. Okay, so let's try a couple problems and see how you do. All right, I would actually really like you to try these without me and then just check with what I got. Okay, so 7 to the third times 7 squared. So if we do that, we should have, you don't even have to expand it out if you know the rule. It should just be 7 to the fifth, because 7 to the 3 plus 2. Okay, second one, if I add 4 and 1, I get 5, and if I add negative 2 to that, I get 3. So we should have 4 to the power of 3. Okay, and the last one here, 8 plus negative 8, that's 0, so 6 to the 0. But hey, we can write that even better. That just equals 1. Okay, so if you got 7 to the fifth, 4 to the third, and 1, so far so good. All right, so let's look at when it's not just numbers, we have some variables here. P squared times p to the fifth. I want you to actually try these by yourself too, and then just check with me and see how you're doing. All right, the first one usually throws some people off because I did not write any exponent here for the p. So you might have to think, well, there is an exponent there for the p. What is it? It's an invisible 1. P to the first power. So p squared times p to the first times p to the fifth. It's not p to the seventh, it's p to the eighth. See if you got fooled or not. All right, and this last one, 2q times 3p to the third times 4q to the fourth. What is very important here again is that this entire thing is multiplication. 2 times q means, 2q means 2 times q. This means 3 times p to the third. This means 4 times q to the fourth. This entire problem is multiplication, of course, with the exception of the exponents. So we could rearrange this in any order that I wanted. So I am allowed to multiply 2 by 3 by 4 at the beginning. The p to the third doesn't go with the q's. Okay, so p to the third, I'm just going to put that next, and then q times q to the fourth. Now I'm going to try to simplify everything that I can. So if I look at my numbers, 2 times 3 times 4, that gives me 24. P to the third will stay p to the third. Q times q to the fourth, don't forget that invisible 1. That's q to the fifth. This is my final answer. I've simplified my exponents. Okay, so sometimes you have problems like this that are in scientific notation and you want to write your answer in scientific notation. So it's sort of similar to what we talked about yesterday. When we had the quantity 3 times 10 to the negative third times the quantity 7 times 10 to the negative 5, remember again that this is all multiplying, and I can multiply it in any order that I want. So I like to regroup it and make it a little easier. I like to multiply the 3 times the 7 together, and I like to multiply the 10 to the negative 3 and the 10 to the negative 5 together. I like to think of it in that same way. Even though a lot of times I don't rewrite it out, I just kind of do that mentally. Okay, so when I multiply 3 times 7, I get 21. When I multiply 10 to the negative 3 times 10 to the negative 5, I need to use my powers that I just learned today. That's 10 to the negative 8. So I have 21 times 10 to the negative 8, but I am not done. And the reason why I'm not done is because 21 is not in between 1 and 10, so this is not in scientific notation. So if I rewrote this, that 21 I would rewrite it as 2.1. So I want you to notice, look, I made this number smaller, and I made it smaller 1 decimal place. So I need to make this number bigger. Right now it's 10 to the negative 8, so if I make it 1 bigger, the decimal place moved 1 time, it's going to be 10 to the negative 7. And that's my final answer, and that's in scientific notation. So that looks a lot more doable. I think I'll give you one of those to try on your own and see if you can get it. So very similar. We'll do 4 times 10 to the 12th times 6 times 10 to the negative 4. Okay, so try that on your own and then check back with my answer. Okay, so again, I'm going to regroup it how I like it. I'm going to do 4 times 6 together, and I'm going to do 10 to the 12th times 10 to the negative 4 together. Okay, and 4 times 6, that gives me 24. 10 to the 12th times 10 to the negative 4, that's going to give me 10 to the 8th. Okay, so I've got 24 times 10 to the 8th, but nope, that first number is not in scientific notation, so I'm going to make it 2.4. Okay, again, I made this one smaller. So it's 10 to the 8th, I want to make it bigger. Okay, to make it balance out, it's going to be 10 to the 9th. If you got 2.4 times 10 to the 9th, give a loud cheer because you're sitting there alone. Maybe you're in school, but that would be fun. Okay, all right, last problem. The speed of light is 3 times 10 to the 8th meters per second. If there are 1 times 10 to the negative third kilometers in 1 meter and 3.6 times 10 to the third seconds in 1 hour, find the speed of light in kilometers per hour. Okay, boy, we get to go back to chapter 3 and work on our unit analysis and see what's happening here. So I have meters per second. I have 3 times 10 to the 8th meters that are in 1 second. Okay, and then I'm trying to get my final answer to kilometers per hour. Okay, so the second thing says there are 1 times 10 to the negative 3 kilometers in 1 meter. I want kilometers on the top, so I'm going to multiply by 1 times 10 to the negative 3 kilometers. That equals 1 meter. Okay, do you remember from chapter 3? That's good because this meter's here and this meter is here. They're going to cancel out. Okay, and then 3.6 times 10 to the third seconds in 1 hour. I want hours on the bottom because I see that here. So I'm going to do 3.6 times 10 to the third seconds in 1 hour. Okay, and the reason why this is good again, because seconds here, on the top and the bottom, so they cancel out. So if you look at my units, on the top, the only ones left is kilometers, And on the bottom, the only one that's left is hours, and that's what I want. So I can just multiply straight across. So I'm going to be multiplying 3 times 10 to the 8th times 1 times 10 to the negative 3 times 3.6 times 10 to the 3rd. Okay? And when I do that, I'm going to regroup it, but I'm not going to write it regrouped. So I will go ahead and multiply 3 by 1 by 3.6, and that gives me 10.8. Okay? And then I'm going to multiply my powers of 10. So I've got 10 to the 8th times 10 to the negative 3 times 10 to the 3rd. So 8 plus negative 3 plus 3, well, negative 3 plus 3 is just 0, so that's just 10 to the 8th. That happens there. So I've got 10.8 times 10 to the 8th. I'm very, very close to done. But again, my answer is not in scientific notation. So I need to change this 1.08. Again, look, I made it smaller. Only 1 decimal place smaller. So I'm going to make this one 1 decimal place larger. It's going to be 10 to the 9th. So I've got 1.08 times 10 to the 9th, and my label is kilometers per hour. That's our speed of light. So you can see that's a pretty big number. A little over 1 billion kilometers per hour. And that's all I want to do for today. I will see you in class tomorrow.